Okay, cool. All right. So I would like to do like the quick show of hands thing so that way I know my audience a little bit more. Who here does JavaScript? All right. Who here loves JavaScript? It's their favorite language and they think like the triple equals is like the best thing since sliced bread. Yeah. We got three crazy people. All right. That's cool. It's a good start. How many people like Angular? I'm sorry. How many people really do React? Yeah. That's the cooler crowd. Cooler, not coolest, but you're getting there, right? Baby steps. And how many people do Redux? Because Redux and React are like, they're like best friends now, right? That's what I thought. And yeah, sure. We can mob something or other, whatever it's called. But okay, all right, cool. Now I know you guys. And I am Kyle. I'm Kyle Kress. I'm at Toastal. I work at Entangled Media in Boulder. I recently convinced them to drop React and switch to Elm. So when I first gave this talk, I was looking for an Elm job, and luckily I was able to convince my employer, so I didn't have to go anywhere else. Right? Yeah, good stuff. All right, so this talk is called Did You Get the Message? Commanding the Elm Architecture and How Elm Can Help You Solve Your Library Overload Problem. So, what is Elm? Elm was a functional reactive language when I first wrote this talk. They bumped versions and decided to rip out the whole paradigm underneath, and I had 2 days to rewrite the whole thing, which is fine because, you know, as I was doing it, I literally had to look at the docs twice. I don't know, it was just a pretty simple migration, but it's now a concurrent functional language that's built from the ground up to be the best language for building UIs. So Evan Chaplitsky, the language creator, decided to build a language. He's like, you know, what would make a cool front-end language? Not like what works great, it's just like what's the best, starting at what would be the best, rather than making it just trying to do it for familiarity's sakes. But you know, before we get more into what an Elm is, how did we get here? So we started with jQuery, for better or worse. So I am no longer quite the jQuery fan that I once was because it's all native now. But you know, it was a good tool and we all used it. So, but what failed and why have we moved on? So what we were all doing is we were building up DOM and we were putting state on our DOM. There would probably be like 40, 60, 80 data attributes along the whole thing. We all know that the DOM is slow, querying the DOM is slow. Well, particularly like insertions and things of this nature are really slow with the DOM. And when we'd say we want to store the state of, you know, a checkbox or something, we would then put another attribute, a class name or another data attribute on our DOM. And at that point, it's like, what is the source of truth? You know, where if I were to ask you, what is the state of your app? And you'd be like, well, it's some of it's in the backend, the PHP code. Some of it's on the DOM. We've got a little bit in the JavaScript. I don't know. And you go to QA, and then they're like, they give you like this, you know, like 15 long lines of like laundry list of how to get to that, you know, that bug, and you'd be like, works for me. And you know, it's things like this. It's like state is the problem. That's always been the problem, right? And so after this, we switched over to things like the backbones and the embers and the angulars, and they just nothing really game-changing happened with those. They made a couple things a little bit nicer, but we're still sticking data attributes on the DOM and trying to get it to reflect the state, and the state's kind of somewhat in the DOM, somewhat in the code. Where is it? I don't know. So the biggest game changer was React. And anybody who started with React starts with React set state, and it's built-in state management. And so now we have decoupled ourselves from the DOM. So the DOM is no longer a source of truth. But you know, it's not a perfect thing. So set state is ultimately an imperative API. It's very controlled, but it is imperative. And when you're using set state, you can't use the pure render option because React does the right thing and assumes developers are going to make mistakes. They're going to accidentally write mutable code, so they're constantly doing a diff to check that you didn't touch things. And so even though now we're decoupled from the DOM, we're now coupled to the element. So when I go back to what is the source of truth in my app, where is it? I'm like, well, it's not on the DOM anymore, but if you query my 25 components, now you can kind of get the understanding of where my DOM is. And as you start to build a React app with set state, you have to find a way to pass down your state into lower components and bubble them up to higher ones. And it's not fun. And it gets really confusing. And you're literally just like creating event handlers at top levels and then just passing them down, down and down and down, and then they bubble back up. And yeah, it's confusing. So what React really tried to push everybody into was the set of Flux libraries. And it is a story of stores and the data flowing in one direction. So with the Angulars and the Emulars, we had the two-way binding, where the binding was both in the DOM and in the code, and it wasn't as clear how it updated. And with the single data flow, it's like, hey, I do an input, it goes back down, something grabs the update, pushes it out to the view does an update, and it's just a single flow. So here, the winner was Redux. And as I saw, most of you guys who did React have touched Redux. And Redux seems to be the de facto way to do state management now in a React application. There's some other things like MobX, and there's a couple other things, but Redux seems to have been the winner. And the first thing they try to tell you is don't use local state. Don't put state in your components. Put it all in a single state atom. Like there's just at the top of your application, and it says, hey, this is my global state. Whenever QA says what's the state of the app, you say, look at the store. That's the state of my app. And discussion. So long as you're letting everything follow in line with that. So the minute you let one of your components do set state, now you've kind of broken some of the Redux paradigm, and it gets a little bit uglier. So at that point, once you start using Redux, you start to notice that your app migrates from a React app to a Redux app, because now it's just how do I update my stores? How do I how am I managing my state? And React just becomes a view layer. It is a reflection of the state. So when the state updates, push it out to the view renders the differences. So at that point, you start querying only the store and never the state. That's great. So my question to you is, where did Redux get its inspiration? The Elm architecture, literally. If you actually read Dan Abramov, I think is his name, his docs literally say, I got this from Elm. Elm is doing great things. It's such a good idea. I'm backporting that into JavaScript. So this thing that becomes the de facto React standard has actually started in Elm and has been maturing in Elm as well. And that's where a lot of people are getting their inspiration. There are libraries like Cycle and other ones that are also trying to use this architecture. So let's take a quick look at the 2016 Front-End Developer Toolkit. So I'm sure you guys are all familiar with your Babels, your Redux, your Flow, your whatever your utility library is, and then you got a view library, and you got linters and test frameworks, and it's just not the same way in Elm. So in Elm we've got everything is just built into the language, right? So instead of Babel, it's just a compiler. There's just one compiler. Redux, which is it's a whole library for state management. In Elm, it's a design pattern, and pretty much the only design pattern. It's just part of the language. That's the thing. Instead of having to deal with Flow or TypeScript or dealing with any of these typings, it's a language with Hindley-Milner style type annotation. So it's strongly typed the whole way through with type inference. Instead of these utility libraries, the standard libraries actually have things in them. So for the view layer, instead of using React, you use Elm HTML, which is now packaged by default in with the core, so you always have it. The Elm formatter, imagine if ESLint had just one config file and there wasn't a config file, just everybody in the language does the same thing. You hit save, bam, your code looks like everyone else's code. That's not that way. It's not the way like that in JavaScript at all. Like everybody has their own config files. Some people are like Airbnb and all this stuff, and it's just not like that. Just everybody uses the same tools. Everybody's code looks the same way. It's really easy to follow because there's no mental overhead of trying to understand where these people got their coding style. So this is probably my favorite image, and for me, this is React in a nutshell. So when you're building a front-end React application, you are literally just bolting tools onto your language to get it to behave in a way that it wasn't really built to do. You know, it wasn't built to do a single data monoflow. And Elm is just like, hey, we packaged it all. It's in this one nice shiny box, and that's all. You npm install Elm, and you're ready to go. So I'd like to do a quick flyby for Elm syntax. Has anyone here touched Elm? Know anything about it? All right, so we got a couple hand raises, so we will definitely need to go over this real quick because I will be doing a little bit of live coding and showing a couple examples, and it's nice that you know what is going on. So there's a couple different literal styles. We've got comments, block comments, booleans. Numbers can be both ints or floats, depending on what you're trying to do here. Characters are used single quotes, strings are double quotes. Lists are all cons lists for people who've done any research or know anything about Lisp. So all of these are different ways of constructing lists. This is called the cons operator, and that conses this list and makes this list. Those two are essentially equivalent. Functions are built like they start off with a type annotation. It's optional, but it helps. It's a way of documenting your code and explaining the inputs and the outputs. So in this case, we have a float, and we're going to a string, and so the first thing is your constant, and since it has since Elm has first class functions, just kind of like JavaScript, how you can say var my variable is equal to a function. We start everything off with a variable like that, and so if it sees an argument, it knows that we're a function. It's also curried. So no matter how many arguments, for every argument you say that it's going to be there, it returns a function until it completes, and then it returns the end result. And so the equivalent in JavaScript would be this kind of thing, where we're required to declare that we're having a function. We have a return statement, instead of an implicit return statement. We don't have the type annotation, and it also does type coercion, right? So if I pass in an integer and I try to concat a string, it won't throw any errors. It will make a string, which is, kind of nice in the short term, but in the long term, like really, you want to know that your types line up. You want to know what came in, what went out. That's why things like TypeScript are really taking off. So here are some examples of union types. They can be created just kind of like a Java enum. It's also called tagged union. You can tag data on them as well, and that becomes super useful for message types. So anybody who's done Redux, your actions all have a type, and then usually they have some sort of payload, and this kind of wraps that whole thing in just a data structure, right? So it's, here's my tag, here's my data, now I can know exactly where I'm going. And one of the most popular union types is a maybe type, which is a way of wrapping up the case of null and undefined. So in a lot of functional languages, there is no such thing as null. So you never have, undefined is not a function, cannot find property of undefined. These types of things that you run into in JavaScript as a developer, and you're like, what the hell is that? Like, where did that come from? And you're literally just trying to figure this out. Well, you're required in a language like like Elm or Haskell, or they have option types, I think, in the Swift, and it's a way of wrapping your data. So, you know, if I have a maybe int, then it contains either a just int or nothing, and because of that, whenever I try to use this value, I'm required to either map inside of that and change the value on the inside and then use it later, or pattern match out that value, which means I'm always handling the null case, and it can never happen. It just can't. And like I said, this is the case statements, and this is how you'd match it out. If I said I have a maybe int, and I can match out the x, and I can, on the nothing case, I can say, hey, you got to be a 0, and now I have a case statement. In Elm, you can also do head-tail recursion in a case statement. So if we were doing a list length function, we could check and see as an empty list. Otherwise, let's split head and tail until we get down to the very end, in which case, when the tail is empty, it adds 1, and that finishes our value, and we can get the length of a list recursively. There's also the thing called a record type, which looks a little bit like a struct or a JavaScript object, and it is a typed thing. So you give it a key, and you give it the type of the value, and you can create values just like that. So in the case of a point, we have an x and a y, and to update that record, you use this this pipe operator, which is known as like such that. So in the case of our p prime, it's the first point such that x is 2, and it will return x2 y1. One thing to note is that this does not mutate the record; it returns a new record. So the whole language is immutable. So just like your immutable JS and all these things, it's all immutable all the time. So to quickly go over some of those things we talked about earlier, big question people always have is, what does Elm compile down to? It compiles to ECMAScript 5, just like Babel. You can skip Babel, you know. And ECMAScript 5 covers everything that you should care about. If you care about anything less than ECMAScript 5, you stop working for the government. Because really, like, those are the only people who are still doing ECMAScript 3. So in the case of, if we're trying to replace that one piece of our library overload of flow, Elm is a strong statically typed language with type inference. So this code here will fail, and I will show it real quick. So this is that code. So right here I'm saying that the HTML is of type string. 42 is not a string. Yeah, I know, it's crazy. So the thing is Elm will tell me that. It says, hey, it's a number, we're looking for a string, please correct that. So if I tell it that I'm taking an int and compile it out and refresh the page. Oh, no, it has to be a string. So we will run a toString on this. So we'll say 42 toString. 42, hey, it's wonderful. It also has really cool and good error messages. So I actually messed up this spelling in a spelling bee in 2nd grade. So say I did this. It was a total accident. But look at this. Cannot find variable view. Maybe you want the following. So the compiler is constantly telling you, maybe you wanted this other thing. Like, you probably did this wrong. And so what's interesting is some of the plugins, like there's an Atom plugin and some of the other ones, if there's like a single case that it could be, it just completes them for you. So it just says, oh, you spelling errored, here, take this, your typo is now gone, and it now works. So, I mean, that's really cool. For me, that is super useful. I'm terrible with typos, and every day when I'm coding this stuff, like, Elm's sitting there saving me. And I really appreciate when Elm is doing that for me. So we can also talk about our utility libraries. So Immutable.js, Mori, Lambda, Lodash, underscore, all these guys are literally saying, hey, JavaScript standard library doesn't have things like zip. It doesn't have ways to easily map over objects. You have to do object keys map and then turn the map into a thing, and it's not fun. It's not easy. So almost everybody pulls in one of these utility libraries because the language is severely lacking. And so Elm's core actually comes with lists, arrays, sets, dictionaries, strings, and maybes. And like I said, with maybe we don't have to worry about null or undefined in our code pretty much ever again. It just doesn't happen. And Elm HTML supports everything that we need in the DOM. So we're done with the React side too. And we also have functional composition too. So if we go over to standard library, we can see that we're into our view function. We are pushing a list of strings. And you see that because we're curried, we actually skipped the argument here, and the argument will be supplied at the end of this. So in Haskell, we put a dot. Elm likes to have infixes that make a little bit more sense, and it kind of describes the data flow. So whenever I pass in this list, it does a list.map on exclaim. So any of you that have done array map, you would know that it changes every value in the array and then returns a new array. So here we're adding this exclaim to each value inside of here. So we have hello, darkness, and then we're doing a join on them, and then we're pushing them into this heading DOM, which is an H2. We shouldn't do that. We should write. So in our example, we'll go back and standard library. Only HTML. Looks like we got an error. Expecting a string, and we've just got one. So we say we have an HTML of string. And view also doesn't have a string. I did this on purpose, by the way. And you can see that we have now spit out all of our DOM. Let's see here. And equality checks. That's one of the biggest reasons why people say you should use immutable JS, because how do you check and see if objects are different? These are nested things. You have to loop and iterate over all lists to see if values change, because you can't say, is an array an array? You just can't do those things. So the equality check in Elm is something that makes a lot of sense. It's called double equal. So in this case, we have a function. So it's true. So here we have these two lists, and we're saying, are these things equal? And that's the end of the story. And so if I wanted to put in a 6, you see now that it's false. So you can do this on records, nested records, lists. Literally everything has the ability to just do an easy equality check. And you don't need a specific library. You don't need to write a function that checks if these, like I'm trying to think of other languages that require this thing called deep equals. Like you're pulling in a utility function just to do an equality check. If we're in like math class or something, we're trying to say, are these sets equal? Just use an equal sign. So why can't we just use double or triple equal in JavaScript for these objects to be equal? So this is another thing that Elm will help alleviate. Okay. So the interesting thing next is we talked about Redux and how Redux can be a design pattern. So what does that look as a language? So we start off with an init, which is our model, also known as like our state. We also have a view function, which takes one of our models and returns an HTML of type message. The messages are like Redux actions. So we're saying, given this model, return me some HTML that outputs me messages that match the type of actions that we're trying to get out. And we also have an update function, which takes a message in a model and returns a new model. So it's something like a reduce or a fold, but you can think of it as a fold P, which is what it used to be called, and fold P stands for fold to the past. So we start with our initial state, and as things happen in our app, we are taking values and we were adding values into our model, and we're returning a new model with the new data that we have accrued. So I mean, you could think of that as like, you know, our scientific understanding, right? We started with nothing, you know, we hit some rocks together, and now all of a sudden we've got pointy edges. So now we have a new state of our knowledge. And that is pretty much the whole gist of the update function, which is the same as the reducers in Redux. So I will do a quick live coding demo to explain and show that it's actually really, really terse. So let's go to the live code. So I've started with the boilerplate and most of the inputs that I'm going to need for this, the imports. So we talked about the init, right? And we said the init, or first we need to define what a model is, right? So we say model. And our model is going to contain a reverse. We're going to make an input where when I type in the input, it reverses the string. That's not super cool, but it's a really easy example, and we should be able to easily follow that. So we say it's like that. We define our init, which is a model. And we'll start with empty string, because that's what inputs start with. Now we need to define our messages, or our actions. And this one will be a reverse message that contains a string. So this is like those union types. We'll do an update function, which takes a message and a model and returns a new model. So message, model. And in here we do the case statement and pattern match out what we're looking for. So the case of our message reverse, which is going to have a string, and we're going to say we're going to update the model with our new reverse value. Okay. Then we have our view, which takes a model and returns HTML message. So we can do some destructuring. So we can destructure out the reverse. We'll create a container div. So in Elm, HTML, the HTML library, all elements, they are binary functions, meaning they take two arguments. First argument is a list of attributes. Second argument is a list of nested nodes. It's pretty similar to the React.dom API. And if you're not using JSX, you can use react.dom.div. And now you have a function, and the first argument is an object of attributes, followed by a spread of the rest of our elements. So Elm doesn't, most functional languages don't really do spread operators. They will say, just give me the list. So it's always two arguments, no matter what. So you never pass in null, you never skip any of these things. They're all the same way. So it's pretty easy to follow. So we will create an input. Actually, we have plenty of screen real estate. So of type text, placeholder, reverse me. And then our value is going to be the reverse. And we're also going to have this events, which is on input. So on input, we are going to tag it with that reverse message. And that will say whenever on every input, the input.value will get tagged with this reverse message so that we know which action, which message we're dealing with. Okay. So, and then we create, we're going to create a div for display. It's going to be text string.reverse reverse. Random design model. Oh, silly me. Okay, you saw the auto format. Automatically format that. That was pretty cool. I like that. So if we go to our live code, we now have a reverse me. We can spell cool words like kayak or race car, and they work. And that's pretty neat, right? So that's like the React 101. This is what they show you, right? Like how to do some little toy example like this. Except we did it all in a file, and we're at 46 lines of code, right? And like most of this is like Elm's really judicious about white space, which is pretty neat. So if we wanted to extend this, say, and we wanted to have the ability to shout and say that's a string. So we should get an error. So this is showing what the error is output like. It's like, hey, so you said your model has a shout. The init does not have a shout. What are we supposed to do? So I put that here. Now this is happy again, but we're not doing anything with it. So we're going to need to create a shout message. So you can see here. So now this is kind of cool. So it says you need to take account of shout. Your case statement isn't branching. It's not accounting for all possibilities. So because of the type safety, it's pretty much telling us like you have to have these things. If you don't have these things, then we won't compile. And once Elm compiles, the code's normally pretty good. You don't actually have a whole lot to do at that point because of the compiler checking this for you. So we say shout equals let it all out. And these are the things we can do without. Let's see here. So copy this line, paste it, replace. So change word, shout. Oh, nah. So we'll call this shout. Shout. Destructure out the shout value. And we will do string to upper. Shout. Looks good, right? So now we have these, and if I want to say Denver is sweet, we now know that Denver is sweet. Thank you. Yeah, that's pretty cool. So we'll add one more thing here to this. So let's create an exclaim, because that's what I've been doing this whole talk, is exclaiming. So we will need on click. We'll need an on click event. We will need a button. And we will come down here. We'll create a button. So button, type button, text, exclaim. Okay, cool. So now we have this error again about not handling exclaim, which is cool because that's the thing that we need to handle. So exclaim does not actually have a value on it, so we'll break it down like this. So we'll take the reverse value. That will be model.reverse, so that will get into the value. And we will add an exclamation point. So YYP. Oh no, quit. All right, change. Oh no. Change shout autocomplete. And now we have this, and Denver is cool. And our exclaim does not work. That is a bummer. You know why? We didn't have an on click, did we? So on click, exclaim. That might ruin it. So she shall, and snakes. So that's our example, our toy example. It was pretty sweet, huh? Yeah, I thought so too. So, people like to know, how do you get Elm into your existing app? So you run a command line, Elm make, and you tell it the output file, and it creates an object that you can then reference, and you can either import it, and you can just start using it. So at that point, you'd say like Elm my module, like that one is called live code. So elm.livecode.fullscreen, run, and then it will take over the body element, and your Elm app just starts running. So here's one cool thing to note. This is some benchmarks. People like benchmarks because that shows how fast things are. So some of these libraries are a little outdated, but this is React 15.2. So we are at, this is actually a benchmark out on this link, and I ran this on my own Linux machine at home, and it was 438 milliseconds to run essentially the to-do app, to uncheck, check things, and make, to see how fast you can run a to-do app. And we can see some of the other immutable languages out there, like Ohm. Ohm is pretty close, but you know, it's not as fast as some of these other things. So Mercury is pretty quick. That is a JavaScript library that has its own virtual DOM. Plate is a JavaScript library built on the Elm architecture. But what matters here is this is Elm. This is the current version of Elm. It is at 210 milliseconds, which is twice as fast as React. And then when you introduce the idea of lazy, which does a short circuit and a memoization on some of the stronger, the more difficult spots that need diffing, because if you know about virtual DOM, it does diffing and patching of the DOM. So if you add lazy to it, you get it down to, in this case, 61 milliseconds, which is like several orders of magnitude. I don't math right now. It's faster, and that is really, really fast. So right now, Elm is the fastest way to render things, except maybe the Inferno thing that I'd heard about at the React.js thing in Denver here recently. But it is fast. It is fast, and it gives us these guarantees of the type system. So if you wanted to go deeper into Elm, there's effects, there's commands, and subscriptions. So anytime you're building your own ports, or you're doing rest or time, or these types of things that interact with more than just some user events, things that happen passively, you get into that system. The ability to nest components is definitely a thing to look up, and that's kind of having an internal state of a component. It only cares about itself. It doesn't worry about updating other things. But that still lives on your main state. And results and error handling. Those are also things worth looking up. So at this point, I'd like to say, sorry, React. You know, it's not that you're a bad framework, and some of our best times have been with you. And you've taught us a lot about who we are and who we want to be, you know, as developers. But I've looked around, and I know I can do better. And I think that better thing is Elm. So it's been real. Thanks, guys. So Q&A?
How long do you think if we will be doing this presentation to saying sorry to Elm?
You know, GHCJS could kick the tires in a different direction, but I think Elm's influence on the React community and the reactive stuff in some of the functional languages I mean, its influence will still be there. And so the knowledge that I get from doing this isn't going to go to waste, even if I switch to something else. So what's up?
talk a lot about kind of what's enforced at the language level from a typing, kind of like we could go to TypeScript as you mentioned. Is there anything enforced in terms of kind of file architecture or anything like that that Elm recommends, or kind of a CLI tool around it, or similar to what you see with like Ember or what they're doing with Angular 2, so you have kind of a consistent pattern to the way your front end's written? Or is that really up to every time you start a new project?
The question was, is there an enforced architecture file structure? And the answer is no. You can kind of do it yourself. You could put it all flat. You can stick it all in one file. That's up to you. So I know me personally, let's see here. So CD, Unity, oh no, Unity, let's do web client, CD source, Elm, tree, which actually isn't super useful. All right, so my structure looks about like this. So generic components live in a components folder. I have my APIs in one folder, and I have my types, some generic top-level types in those, and then everything else I put in feature folders. So videos has its own routes, it has its own routing, it has its own update function and its own views. And everything else is just sitting at the top because these are the generic things. This seems to be the best structure, at least from my perspective, after re-architecturing the file system like 3 times in this project already. So any other questions? You there in the back hat.
Do you think that popularity of Elm grows and everybody prepare with the
The question is, will browsers implement an Elm compiler? No, they won't. And what will end up happening is, at least my current prediction is, WASM takes off WebAssembly. WASM, WebAssembly. So when WebAssembly takes off, then any language can compile to whatever the browser's assembly code is, like most languages compile down to some sort of assembly machine code type thing. I do not think that they will ever build anything in. So any other questions?
Aside from performance, what was the main reason that you switched away from React?
Okay, so the question was, aside from performance, why switch to React?
Away from React.
Me specifically or in general?
You specifically, maybe both.
Okay. In our application, we had somebody who over-architected a React application. He put OO classes around all of Redux that all had internal state, which is kind of no-no in React or in Redux, which is like, hey, this is functional. Use this functionally, please. And it just kind of gets in the way. Along with that, a lot of the React components were built in a non-performance view. They weren't looked at performance-wise. They just built everything out. And then whenever we actually started throwing real data, like lots and lots of data to test the app, it was too slow, and we couldn't actually release for alpha because the performance was so bad. But pretty much, like one of the strongest reasons is, we talked about all these different libraries and things that we are sticking on our JavaScript to like make it behave a certain way, and so now we need to learn 16 libraries and 3 test frameworks. And in an Elm, there's just kind of one library for everything, and the community always contributes back to making that one library really good. There's not a whole lot of alternatives. So it's more about getting the speed, getting the type assurances, and having less overhead of needing to learn a multitude of libraries. Does that answer your question? Okay.
You talked a lot about what Elm does good. Do you have any insight into something it might not be so good at?
The question is, what does Elm not do so well? And so one thing that it kind of lacks is higher-kinded polymorphism. So I can't make very generic things. So you see things like list.map. You see maybe .map. There's no map, right? There's no generic map, and I can't do some really, really nice generic things because of that. I can't have functions that handle many different types of things going into them. That's been a pain point. And currently, it's still a growing language, and so they're trying to wrap as much of the web API as they can, and they haven't covered it all because there's a lot of stuff. So you have to break out into ports and do things in JavaScript occasionally to get around them. And it's kind of a pro and con because you can also get things from JavaScript. You're not purely limited, but not everything is there. And sometimes the community can be a little strange because they want to be really nice to newcomers. And if you're like an advanced user who's studied some of the functional stuff, and you come in like asking about higher kind of polymorphism, they're like, you shouldn't be asking that. Or if you look into the native code and like I was asking a generic question to the Slack group, I'm like, so how do you send in a unit from a port? And they're like, well, it could be an empty object. Maybe it's an empty array. And so I go pull up the native code, saw that it was null is what passed in a unit. And I'm like, well, I looked in the native code and I saw that it was null. And they're like, why are you looking at the native code? Everything you compile is perfect. And it's like, because I want to understand it. That's why. And so usually somebody will be like, don't listen to this asshole. But that's always seems to be a knee-jerk, is like the first answer when you ask about something in depth is like, why are you asking those questions? And I kind of understand it because they're trying to make sure that you don't have a bunch of Ruby people coming over and trying to do, OO stuff in an FP language, because they used to open up their native library, and it became a problem because people were writing really OO style stuff, and it didn't fit the pattern right. And so to get away from that, they're trying to black box some of it, it's a pro and a con because you got the benevolent dictator for life type Python thing, but at the same time, like if you want some rapid stuff or to get your questions answered, sometimes you just have to go look in the code yourself. So, but the performance is there. It's faster than pure script. What's up?
What's hiring for this? Like, it's kind of the idiosyncratic syntax from what I'm seeing. Are you just hiring like JavaScript developers and ramping them up, or?
So the question is, how's the hiring and training process for Elm? And right now, I'm the only one working on it with a contractor who also knows quite a bit about it. But I do know that I think Galvanize, Pivotal, both in Boulder and Denver, are kind of sort of looking for Elm developers to do more of their stuff. And I think that they're taking people with React skills. Because if you know React and you know Redux, you know Elm. Because it's there. It's cleaner and terser and type enforced. So it can go either way. You can hire in somebody from FP. You can hire in somebody from with just a decent JavaScript background, so long as they're not like super into like Backbone or something that just doesn't quite fit the pattern. It's not that hard to learn because there's not a whole lot to it because it's literally targeted just at the front end, right? So it's not trying to be the solution to all problems. It's like we do the front end and that's it. You got another question? Okay.
Just to say along those lines, is there an exit market version for it, or is it purely kind of in the small world, or?
So there's some attempts to convert it to use it for Node, to use it as like a server and stuff. You can do that. It's because it compiles to JavaScript, so you can make these things happen if you want to. But I personally would not really agree with that because, we use JavaScript in the browser because we have to. In the back end, we have good options, so why are we choosing Node? So there's been some efforts, but it's not like the focus, and it's like third-party people doing it because they like the idea or they really like Elm. There's a lot of people that fanboy it that much that they would rather use Elm than like use something else there like Haskell or Elixir or something that could fit their needs. Anything else?
So when it compiles down, to the JavaScript? Does it kind of pick and choose which elements of it you actually use in the process of building it? Or is there any componentization of it where you can take parts of it to make it linear? Or is it you take all of them or nothing of them?
So there was the slide there for Elm embed. So you can embed a piece of Elm into just some DOM, and you can use it as just a piece of your application. You could have several embeds in different spots. They would have their own. They wouldn't have like a global state store, which kind of sucks because now you need to go query all of those. But it's a way to introduce it. There's also some components now for React to inject an Elm embed into a React element. But I would stay away from that because it's a lot easier to just buy in a whole hog, or using the port systems in that if there's like some React component you need, use Elm for the data store, right? Because it's really good at that. It does the Redux thing, but rolls it in itself. And so you could build a small wrapper around that. I've seen a project. I think it was just a toy project, but it was replacing Redux with an Elm store and letting Elm do all the state management, and then like pushing that out to React or whatever other front end thing. It's really good at data storage, and its ability to traverse immutable lists and stuff is some of the fastest out there. So you can reap those benefits if you're not willing to give up all your precious JSX. So are we out of questions now? Oh, we got another one.
DHC.js and PureScript both be so much more language, so it almost seems like very, very limited. What is going to compel people to use DHC.js stuff around or PureScript, like a little slower, but just very robust?
Okay. Question is why Elm over PureScript and GHC.js? Easy performance. Like, it's so much faster. So you got to understand that the front end is a performance playground, right? 60 frames per second, right? Like, performance really, really matters in UI. You can't have somebody clicking and then it delaying. You need something super fast. And right now, the PureScript team isn't really trying very hard to work on performance. And the GHC.js team is focusing on performance, but they've got a lot more work yet to get their compiler all the way out. And I think it has a good chance to overtake it, but I think for right now, it's the fastest tool for the job, especially if you're trying to pick the immutable, functional, FRP-ish style front end things. All right. Looks like we're good. All right, guys. Thanks.